Multiplication theorem of probability. In this video we will look at the multiplication theorem of probability. It states that for two events A and B, probability of A and B is equal to probability of AB multiplied by probability of B. Probability of A intersection B equals probability of AB multiplied by probability of B. When A and B are independent, it follows that probability of A intersection B equals a probability of A multiplied by probability of B. In other words, the probability of simultaneous occurrence of A and B is the product of the two probabilities. Generally, for n independent events, the probability that all events occur is the product of their probabilities. Then, probability of A1 intersection A2 intersection AJ up to intersection AN is equal to probability of A1 multiplied by probability of A2 multiplied by probability of AJ up to multiplied by probability of AN. Let us consider the given example. An electronic system consists of four components of identical functionality. The system becomes dysfunctional only when all the components are dysfunctional. The functionality of each is independent of the other. The probability that a component is functional or dysfunctional during the guarantee period is independent of the other, and it is 0.9. What is the probability that the system is functional during the guarantee period? Let AJ denote the event that component J is functional. Then probability of AJ is equal to 0.9, where J equals 1 to 4. The probability of a component being dysfunctional is probability of AJC, which is equal to 1 minus 0.9, which is 0.1. The probability of the system being dysfunctional equals probability that all components fail. Thus, the probability of the system being functional equals 0.9999.